Real quick, Algebra 2 refresher for the next week and a half or so, and then we'll have an Algebra 2 exam. I call it Chapter R for review. A lot of this is in your textbook. At the very, very, very front, it's called Just-in-Time Review. Some of it is not in there, but it's stuff that you're going to need. So if you don't find it in there, that would just be me saying, hey, this is going to come up. You need it. We're going to start with something you may not even remember or may have never seen before. That's okay. That's like the only thing that might be new. And that would be the family tree of numbers. So we're going to organize this. We're going to learn some vocab words and some symbols that you are going to see throughout the semester. So the largest group of number category is whether it is real or imaginary. You got your real numbers, you got your imaginary numbers. Okay, that's the very, very beginning of the number system. We are going to focus on just the real numbers because they're the ones that actually break down into smaller subcategories. The imaginary numbers are simply that. They're imaginary. They have an I in them to let you know that they're imaginary, and we will talk about them another time. Bless you. So focusing on the real number system, I want you, you might want to wait until I get it on the board, and then you can kind of, or it's going to end up taking up a lot of room. So I don't know, it's up to you on how you want to do this. So the first one, in focusing on the real numbers, is the symbol for real numbers, which looks like a capital R, but it has that extra bar in front of it. So you could draw basically two L's, lowercase l's, and then just connect the back one to create the capital R. That's one way to do it. That symbol means real numbers. You should have seen that at some point, most likely. The real numbers then break apart into two categories. So we're kind of doing like family tree. We have irrational and rational. Irrational, think of it in terms of like if a person was irrational, it means you can't deal with them, right? They're not coping, not processing correctly. In that case, you want to just calm them down and not try to talk to them. If they're being irrational, can't cope with them. If it's an irrational number, can't make it a fraction. See what I did there? So if it's an irrational person, can't deal with them. If it's an irrational number, cannot write it as a fraction. So for instance, 0.232, 4, 6, 8, 12, 13, 17. I'm just going. I have no pattern. I'm going to keep going. You can't write that as a fraction. There's no pattern to it. It just keeps going. It's irrational, right? Rational is numbers that can be written as a fraction. The prefix here is the word ratio. Ratio is the fancy word for fraction. If you can write two numbers as a ratio, it's a fraction. You're comparing two numbers together. There's a symbol for rational numbers. It's not that. Hold on. The board took more. Oh, I know what it was. Anything that the board, it touches the board, makes the mark. The symbol for rational numbers is a capital Q. Why do you think it's a Q?
Quantitative?
Keep going. I like guesses, by the way. That's not quite it. There's a fancy math word for fractions. Keep going. Y'all haven't used this word probably since the very first day. What?
Quotient.
Quotient. Remember that word? Quotient? Quotient is the comparison of two numbers. That's that fancy math word for fraction. That's why they call this rational group. The symbol is Q, meaning it can be written as a quotient. Okay? If you need to make that note, then please do so. Now, so rational numbers are numbers that can be written as fractions. That group then breaks into two categories. One of the categories is called integers. Notice where I'm writing it. It's called the integers. And the other category is very fancy, and this is one of the things I love about math. A lot of things just make sense. They didn't try to get creative and stupid with it. So we have the integers, and then we have the not integers. Very, very complicated. So it's either an integer or it's not. And if it's not an integer, it's not fun. If it's an integer, that's where the fun happens. So the abbreviation, the symbol for integers is a capital Z, but you kind of do like they did with the real numbers, and you add a bar in the middle to show that you are representing the symbol for integers. So the way I do it is I draw a Z, and then I just do a second line there. Now, technically, the Q is supposed to have a second line somewhere, like around the O, but I can't do it good, and it drives me nuts to do it wrong. So. Now, why are the integers represented with a Z? I don't know. I haven't come up with anything fancy for that. What are the integers? They are the numbers that run from the negative infinity direction to the positive infinity direction, and I call them the number line numbers. Because if you were to label a number line, they are the numbers you would most likely put on there. It does go from negative to positive. Those are the integers. Now, inside the integer family, we can then look at two different types of numbers. We have, let's branch it off into two. We have the negative integers. So that would be the numbers -3, coming from negative infinity, like -3, -2, -1. Now you might think the other family would be the positive integers. Yes and no. Yes, it is the positive integers, but it actually also includes the number 0, and so it gets a whole new name, which, no pun intended, are called the whole numbers. Now, you probably thought that the integers were the whole numbers. A lot of people think whole numbers are the numbers in that category right here, but they're technically not. Whole numbers actually are the numbers 0, 1, 2, 3, and on. And I feel like Billy Mays here. Do you know who Billy Mays is? Oh, wow. Man. Streaming TV has just because he was a commercial. It was an infomercial. He was this guy with this big beard, and he was screaming at the TV, "Oh, wait, there's more!" And it was always this mop that would do like 6 things. And buy today, and we send you an extra one for $9.99. I have more. There's a whole other family right here. The whole numbers. Split it off. And I'm going to have to shift because I've run out of room. The whole numbers can be broken apart into 2 categories, and that would be the number 0 itself, the number, and then what we call the natural numbers. The natural numbers have a symbol for them as well, and thankfully it's not tricky. It is capital N, and do a little bar, a little extra bar to show you are talking about a family of numbers. Now, what are the natural numbers? Well, if it came from the whole numbers, and we just took 0 out, it would be the numbers 1, 2, 3, and so on. Now, you might be wondering, how in the world am I going to remember this? First of all, you're going to have to study it. Might not really require flashcards, but just look at this. Read it in your head. Say it a couple of times. You're going to see these symbols a lot. Real numbers are every number that we're going to deal with, as long as it's not imaginary. And then rational are the numbers that are nice and pretty, can be written as a fraction. Integers are number line numbers. You can name it that if you want to. Then you have the negative integers. Then you have whole numbers. Then you have natural numbers. Here's how I remember whole numbers. This is stupid, but it works. I need a different color. I don't like red. All right. 0, right here. Right? Whole numbers. That's how I remember whole numbers. Whole numbers include 0, and I always think of the spelling on the word whole. Whole numbers. Start at 0 and count. And then natural numbers, I think of what is the natural way to start counting. You start with 1. So make a note to yourself, natural way to count. And that'll help you remember that the natural numbers start at 1, but the whole numbers start at 0. Y'all good on that? I'm going to change the screen. Has everybody got? So go to some more space. Stand by. Yes, ma'am, and the doctor just faxed it back to me today. Period. I'll put it in his folder tonight. Okay, so we've talked about the numbers in the entire number system, the family tree of numbers. Now let's go back to the phrase rational. And let's talk about the actual definition of rational numbers. I need you to see how complicated the definition is to know that, so that you understand, while you know what a fraction is, now we need to start understanding the college level definition of things, because you're going to see it, you're going to hear it, you're going to be writing it. So rational numbers are the numbers that can be written as fractions. Remember, that is the fancy cube, as best as you can make it fancy. is the definition. I'm going to write the whole thing. You can copy it down, and then I'm going to explain to you how to read it. Because when you first look at it, it's probably going to be confusing. It would be numbers of the form P over Q This is comma, so where P, comma, Q, that is like drawing a C with a line, so it kind of looks like a curved E. And then that's that Z symbol for integers.
What does it mean?
I'm going to tell you. I got you. Don't worry. Sometimes I think it's better to just write it all down and then let me tell you what it means. Have y'all ever heard of shorthand notation? Before typewriters and all that, there was shorthand notation where you did symbols for words so that you could take really, really quick notes. And it almost looks like hieroglyphics if you really found like all shorthand notation notes. This just has a couple of symbols in here, and that feels confusing. So now that we've written it, let's look at it. We already know what rational numbers are. Don't let the leveled up college definition confuse your already foundational understanding of rational numbers. Rational numbers are fractions. So this is saying it's numbers of the form P over Q. There's the fraction. Then they're given a rule for the P and the Q. They're saying that the P and Q have to be elements of, meaning in the family or coming from the group. So elements of the set of integers. There is a restriction. Q cannot be what? 0. That makes sense. You've learned ever since you started dividing that you cannot divide by 0. So that makes sense. So they're saying Q can never be 0. Then they're clarifying that if you have a decimal that terminates, that's a fancy word for what? Ends, stops, cuts off. So if you have a terminating decimal, so one that stops or ends, or if you have a repeating decimal, that means there's a pattern. They are considered rational. Although they look like decimals, because there's a pattern, or because it cuts off, it's finite, you can write it as a fraction. So repeating means there's a pattern. So we're going to read it again. All right, so rational numbers are numbers that are in the form P over Q, where P and Q have to come from the integer family. Q can never be 0. And by the way, if you have a decimal that terminates or repeats, it is rational, and there is a way to find the fraction that would represent it. Might not be a bad idea to refresh you on that Z, maybe a little note that the Z is the numbers, whoops, count it right, that's the integers family, don't call them whole numbers. Don't call them whole numbers. They're integers. Whole numbers is a different group. All right, so we're going to look at just a couple of examples of rationals or decimals and irrational numbers. Okay, so I'm going to make a note. I'll change colors. So, for example, 0. Rational or irrational? Rational, because it's understood to be over what? 1. 0 is understood to be over 1. Actually, let's write it like this. Let's do the number that I gave you, and then let's rewrite it over 1 so that you can see the thought process. I gave you 0, and then you said, yep, it can be written over 1. Same thing, negative 17. That's rational, because I can just put it over 1. Both of these right here can be written over 1. Alright, this one's not a trick. This is just to see if you're listening. 13 over 4. Is that rational or irrational? That's rational. It's already fraction. It's already a fraction. What about the square root of 25? That would simplify to 5, which is rational because it reduces. So we're going to make a note that it reduces. 5 can be written over 1. Right? So it starts out as a square root. You might think, ooh, that's not rational, but if you can clean it up, it actually is. Okay? 0.25. It's rational because it terminates. Right? It stops. And I picked a nice one that you're already familiar with. But 0.25 is 1/4. Let's say you're having a bad day and you can't come up with that in your head. For some reason, it's like when you're trying to spell a simple word and you can't spell it that day. You're looking at that and you don't see that it's a quarter. Go to your calculator, divide the numbers you see, 25, by the placeholder that it takes up. So this is tens, this is hundreds. So you would do 25 divided by 100, and it will produce the 1/4. Okay? Let's make a note that this was terminating. Because it's a terminating decimal, I can write it as a fraction. Then what if we had this? What does that little bar mean? There's a repeating pattern. So because we have that pattern that repeats, we can write it as a fraction. Most of the time, your calculator will help you get that too. All you need to do is just type the pattern as many times as you can until the screen no longer allows you to enter, and then hit math frac. Math frac will change it to a fraction. So that is a repeating decimal with a pattern, so it can be changed to a fraction. Once again, rational because terminating. Now, how would you get this one? You would go to your calculator. You do have two parts here. You have a whole part, then you have this decimal part. You would just get the decimal part in fraction form. And then you could do either the middle school technique of changing a mixed fraction to an improper fraction. Mixed meaning whole part, fraction part. Improper meaning number on top is bigger than the number on bottom. Or your calculator actually has a nice little feature, I believe believe it's alpha y equals, and then I think it's the second or third option. When we practice this, I'll show you. Second or third option where you can tell it to take a mixed fraction and convert to an improper fraction. So let's make a note. For now, though, let's just write it as a mixed fraction. So it has a whole part of 1, then it has a fractional part of 6, 7, 3, 4. Then you've got to count the placeholder. Remember, it just tacks on a 0. So this is 10, 100, 1,000, 10,000. And then we made a note that this is terminating. Say it again. Oh, I don't know. I would imagine if it cuts off at any given point, you can write it as a fraction. Well, we're not going to have any that day. I'm not going to get dirty on you like that. Where it goes off the screen, but I gotcha. I'm not going to do that to you. You'll know. I'm going to make a note. Watch out. It's like a GPS. Watch out. Object on the road ahead. Watch out. Look at this one. Pi is irrational. Now, you might think, well, you can write a 1 under it. You can. But the number on top would still be 3.1415, da 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 da. No pattern, no end. Even though there's a 1 underneath there, you still have the problem with the top. So anything with pi is irrational, so be careful. Although pi is a pretty symbol, it is an irrational number. No, like square root of 2 is irrational. So some radicals are also irrational. Because if you type square root 2 in your calculator, it's going to be a decimal that never ends and has no pattern. Which actually brings us to the next section of notes. Well, it stops on your screen, but it actually, yeah, your screen can only do so much. All right, so let's just say real quick, we've got irrational numbers. And that would be numbers that are not rational. Don't you love that definition? Numbers that are not. It's very confusing. I know you gotta watch out.
Is there a symbol for it?
No. No, I'm not. I'm just giving you a little bit more info about just those two. No, this actually, oh, you got plenty of room. You'll be fine. And you might want to even make a note here, numbers that, or think of irrational people, can't be dealt with, you know, numbers that can't be written as a fraction. Here are some examples. For example, square root of 2, square root of 65, and we already said pi. We'll say it again for good measure. Here's why they are considered irrational. The square root of 2 is 1.414213562. Screen keeps going. No pattern, right? It's not going to. Yeah, it's not. You're good. That's me saying to you, there's more, but I don't know it. Square root of 65 is very similar. You get the idea. We're just writing this to prove a point. I am not at all asking you to memorize these. It's just to drive home the definition that if it's a radical of a number that actually produces a decimal with, you know, no pattern, then it's irrational. Okay, so we're going to draw a break in the line of your notes. Those would be all the notes on the number tree for family tree of numbers. Now we're going to do notes on set theory. Set theory is, and actually some of the things we've already written was part of set theory. Is everybody good with that screen? Can I change it? Right. Totally different. Huh? You might. I love set theory.
Oh, set theory.
Set theory, set notation, same thing.
I already
Set
done it.
notation, sorry, you can write set theory and then you can write set notation.
Right, ours, we don't think it matters.
I was gonna get it out this time.
That's a good question.
All right, let's look at this. Squiggly line. If you can't do a squiggly line, do the best you can. Do the best you can. It's okay. Do not, please, 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 don't do this.
Yeah.
Don't do that because that's totally different. That's interval notation. This is not interval notation. This is set notation. So, while I'm not going to be picky on how pretty your squiggly line is for set notation, don't substitute it with a bracket because that's different. All right, let's do the numbers 0, 1, 2, 3, 4, and then let's close it. When we say set, we mean a collection of items. In this case, numbers. So this is a set of numbers. The set includes 0, 1, 2, 3, 4. This is called a finite set because the set has only the elements in it that you see. No extras. It's not like there's none assumed to be in there. It is just those numbers. How many elements are in there? When I say elements, I mean things. 5. If you were to count the elements, you would count 5 things in there. Write this, and then I'll explain it. So draw your set, write an X, draw a very big vertical line, not an L, even like dramatic, more dramatic than an L. And then X is less than 6. The dramatic line stands for such that. Meaning, here's a condition, here's a rule. So this is the set of numbers X such that, meaning here's the rule, X has to be less than 6. Does that make sense? So we're going to say the set of numbers less than 6. That's how you read it. Would you say that the set of numbers less than 6 is an infinite set? Yes, because there's negative infinity, right? And it just said all it has to be is less than 6. So even though this is a very small, like, expression, and I don't have any dots or anything, and I don't see a negative infinity in here, when you read it correctly, you need to realize that it's talking about numbers to the left of 6, and it keeps going. Does it include 6?
No.
No. If there was an or equal to line, it would include 6. So you've got to be careful with that. All right, look at this one. Starting to get into that shorthand.
What is this?
I'm gonna tell you. I'm gonna tell you. Write it down first, then I'll tell you. All right, here's how you read it. Remember, we've already talked about the vertical line. It stands for such that, meaning there's a condition. Okay, this is the set of numbers x, such that x is an element of the real numbers. And if element of bothers you, if that phrase bothers you, then think of it as such that the numbers are in the family of real numbers. But it stands for technically element of. So let's draw an arrow to the little e. Let's write element of, meaning in the family of real numbers. Which means that this is the set of real numbers. Now you've got to visualize that family tree. Real numbers was at the very top. Real numbers is every number we're going to deal with as long as it doesn't have an, what letter? An I, because that would be imaginary. And again, mathematicians named it in a manner that should be self-explanatory. You're either in the real world or you're in the imaginary world, right? So if I say real, then don't get confused and lose your sense of direction. Just know that, okay, so we're not talking imaginary. We're talking any number that can be pinpointed on a number line, even the ugly ones, right? Okay, let's practice some questions. So make a note. Practice. True or false? Georgia's terrible. Oh, sorry. Sorry, my notes.
False.
Sorry, y'all. My notes right here said Georgia's terrible. Okay. I'm gonna write it down. I'm gonna do my 1 like that because I'm afraid if I write the way I really write a 1, I'm afraid you're gonna think it's an L. So 1. Little e. So question 1 is asking, is the number 1 an element of the set 1, 2, 3?
True.
Yeah, it's not a trick. You might look at it and think, when you look at it, you probably think I have no clue what it's asking. But when I read it to you, you're probably thinking that's too simple. You're going to get more comfortable with this notation, and then it's going to all be simple. But this is saying, is the number 1 an element of this set? And the answer would be true. And if you have a highlighter to help you, you could highlight the 1 that's right there to emphasize, yeah, it's right here. Let's do another one. I do. Let me throw you one. Now, just like we practiced an easy one that it is an element of, let's practice an easy one that it's not, so it's obvious. It should all work, but if you come across any that don't, throw them away. We'll get it. Oh, yeah, that's true.
Oh, wait, no, this is bad.
Why is it bad?
It's just like that. Just like this. I mean, you know
what's going to be funny
it's
is,
on this
you know what's going to be funny is I have nothing to lose. I have nothing to
Was it all
lose.
year this year?
Huh? You know what? 2 years of not being the best 8 and 5 team, and it's just gone to y'all's head. It'll come back, don't worry. Is 1 the element, an element of the set that you see in front of you?
No.
False.
False.
Don't overthink it. Look at it.
I don't know.
Yeah, you did. It's
None
all right.
appears.
It's all right.
There's not one.
It's as simple as looking at it and finding that element in there, and you don't see it, so it would be false. So in that case, there's nothing to highlight because the element that we're looking for is not actually in the set. Now that was too simple. Let's beef it up. Level it up. It's okay. My little E looked a little off there, but it's okay. And every time I say little E, I think of a little excavator for my 4-year-old. Oh, he's 5 now.
Truth.
So write it down, because first you got to write it before you can even read it. And unfortunately, there's no symbol for whole numbers, and I think it's because it literally just includes the number 0 and the natural number. So I guess mathematicians were like, we don't need a symbol for an entire group that only has one number difference. So I had to write whole numbers if I'm talking about it. Might be helpful too when you're talking about whole numbers to underline the O in it, just to remind you that it's starting with 0 and counting up. So now let's read it and see if we can answer it. Is 4 an element of the set of numbers x such that, so this first part really is not even helpful, right? We're just saying the set of numbers x such that. It's when you get to the such that is when you start having to think. Such that x has to be an element of whole numbers and even. So that even whole numbers. Is 4 in that set? Yes. Whole number starts at 0, but it says even, so that would be 2, 4, 6, 8. In my opinion, 0 is even, but such that right here. To tell you there's a restriction, a rule to meet. Sometimes it won't have that. Sometimes it might just say, like Z. And in that case, you could say, yeah, 4 is an element of the integer family. Okay, this next definition always gives me a headache when I write it and when I say it because it repeats the word set like 8 times. I know. It's the definition of subset. And you know what a subset is, so here we go. If you have a subset, the strict math definition would mean set A is a subset of set B A is a subset of set B if every, why are you doing this? Hold on. If every element of A is an element of B. Let's see, I should have it. I'll fit it right there because that's going to look weird. Push it to the next slide. And technically, there should be the word set in there 2 more times, but it really drove me nuts, so I really didn't. The true definition is set A is a subset of set B if every element of set A is an element of set B. What? No. Now, let me show you the notation because then you're going to be like, yeah, duh, that's what I had in my head the whole time, and then you wrote that definition. Here's the notation. You would say that A is a subset of B. This is the shorthand notation for subset. That's the shorthand notation for it. If you need a visual, because sometimes that helps, just draw a really big circle, put a B on it, and then draw a smaller one, like an egg yolk, and put an A.
Why wouldn't A be the bigger one?
Great question. Could be, but not in the example. And it's because of the way that I wrote the definition. I said that set A is the subset. So because me putting A as the subset, it's the smaller. Yeah. Your mind wants A to be the bigger one because of alphabetical order. But that's a great question. So that's why the visual helps too. Okay, let's look at 3 examples. Are y'all good with this? Can I change the screen?
Yes, ma'am.
Everybody good? So, for example, the set 1, this looks funny now, is a subset of this set. Looks really funny because you're saying the set 1, those brackets around it mean the word set, is a subset of the set 1, 2, 3.
Is that less than equal to sign, or is it just like a C?
No,
with
it's
a
like a C with a line underneath. Yeah,
line?
yeah. It's like a C with that line. And the way I think of it is, I literally think of taking a hand and like pulling an element out of it, and that's how I remember that means this is a subset. Right. Subsets don't have to contain every element. They just have to contain at least one of them. Does that make sense? Can it contain all of them?
Right.
Could I say set 1, 2, 3 is a subset of set 1, 2, 3? It would be redundant, but yeah, you could say that. Do we say that? Not really, because it's redundant. Now let me show you an example of what's not. Let's do letters now. We've got PQRS. And then I'm going to leave some space. And then we have APRZ. Is this set a subset of this one?
Is which one?
Yeah, I'm sorry. Is the one on the left a subset of the one on the right?
No.
No. So the way you would show that is you would draw the symbol for subset. It's just like not equal to, and you do a slash through. Oh, that didn't look good. That looks like a 9. The slash needs to go through it. Still looks like a 9. There we
The
go.
other way.
There we go. I can't naturally do a slash the other way. It bothers me. It feels weird to go that way. All right, let's level it up. College level.
Is it going to be like 4 is...
Yeah.
True or false? True or false? True or false? Here we go. True or false? Don't holler it out yet, though, because some people like to write first and think second, which is okay. So don't holler it out. True or false? You may have to flip over and remind yourself what those groups are. Don't answer yet. No answers. Might even help to write the examples underneath them so then you can visualize what it's saying. what's the capital N stand for?
Natural.
And those would be
1, 2, 3.
and Z, and that would be
Negative.
So the answer is true.
It's true.
so it's saying, are the natural numbers a subset of the integers? Can you visualize, do the C, can you visualize grabbing those numbers from that set? Yes. So it's true.
Are not. I was gonna ask.
So, our whole, don't answer out loud, our whole numbers, I really wish there was a symbol, but there's not, a subset of natural numbers. Don't answer out loud. Are whole numbers a subset of natural numbers? Think about it. Look at your examples. Remind yourself what those numbers are. Can you pull the whole numbers out of the natural numbers? Yes or no?
No.
No. What's the problem?
Zero.
Zero is the problem. Whole numbers start with 0. Natural numbers start with 1. That's a problem, so no. So instead of writing false, we're just going to put a slash through it. Okay, 2 more, I call these slides. 2 more slides of notes, and then I'm going to give you your practice assignment where we put it all together and you practice, okay? This practice assignment will be graded on completion because we're in the review. It's when we hit the My Math Lab stuff on your Chromebook is when things are graded on accuracy. Now, we'll still go over the answers. I still want you to know if you got it right. I want you to fix it. I want you to learn it. But I'm not going to take points off if you got it wrong, especially because this is kind of like a new language, right? Let's look at the next section of notes. We're going to call it intersections and unions. First slide will be intersections. Then we'll do an example, and then the second slide will be unions, and then we're done for the day. So let's talk about intersections. Now, I use the word members here because I used it last year on my notes, but it also could be the word elements. Members, elements, things, pieces, whatever you want to do. So, intersection is the set of members or elements that are common to both sets. The notation, when you're dealing with an intersection, looks like a gigantic lowercase n without the little, not hook, but the,
Lines there.
what do you want to call it? Stem. How about a horseshoe pointing down? There we go. The stem, yeah, I like that. That is the symbol for intersection. I have water.
U-turn.
Looking like a U-turn. That will be what word? What's the next one?
180.
Union. Union.
Oh.
It's okay. It's okay. It's fine.
It's late.
I know. And we've done a lot. This is a lot.
Oh, my elbow cracked.
Here's my suggestion to you. How are you going to remember that intersection is the set of elements that are common to both sets? I want you to think of in the word and. Think of the in the word and. Okay, so what do I mean by that? Let's write an example and then I'll explain it. So there's two sets. You haven't done anything with them yet, just write them down. You got set A, set B. This would be like me saying, given set A is yada yada yada, and set B is yada yada yada. Find that would be the question. Find, now you gotta know what it's saying. It's saying find the set that would represent the intersection of A and B. Well, if you have a highlighter, let's highlight.
3 and 5 are both right.
So if I'm saying the intersection of set A and B, I'm talking about what is in both of them. So is in 0 in both?
No.
No. 1,
No, 3.
3,
Yes.
5,
Yes.
25?
No.
Do I even need to check the remaining numbers in the other set? No, because this one was shorter, smaller. So the way you would write your answer is you would either add an equal sign here, or I like to rewrite it so I know what the question was. So the intersection of A and B would be the set that contains 3 and 5. Now, if you need a visual, draw a really big circle and then another one with some overlap. What's that called?
The Venn diagram.
Venn diagram. What would be in the middle? The
3 and 5.
3 and 5. Which one? Squiggly? So the way I do the one on the right is I start a question mark. And I just reverse it. But the one on the left always throws me. I don't know.
I do that. One of that's easy. You do 2 S's.
Or where it's backwards.
Well, then just do a question mark and then an S. Right? The one on the right is a question mark and then an S. There you go. So in terms of a Venn diagram, it would look like this.
No, it's S and 4.
So that's what it would look like as a Venn diagram. The common mistake with Venn diagrams is people repeat the numbers that were in both. You don't do that. You just write it the one time, but it goes in the overlap, right? Now, this was one entire example. We have a little bit of room and it's very short. I'll just need to write small. Actually, let me just do this. I'll change color so you can distinguish that this is a different example. And I want you to tell me intersection of those two groups. What are the two groups?
Real numbers and
Real numbers, imaginary numbers.
There's not an intersection.
There is not one. So instead of writing that all over again, I'm just going to come right here and say, now that has a name called the empty set. Mathematicians were very creative. Doesn't mean zero. Zero's a number. Zero's an
I
element.
didn't say zero.
Zero can be found on the number line. Empty means there's nothing there. Like nothing at all. So let's make a note. This, notice there's no brackets around it either because it's empty, right? You only put brackets when there's something in it. There's no brackets around that. It means this is no intersection. It's the empty set. And if you need to, the definition is a set without elements. So because there's no elements, you cannot draw the set bars. It's a set without elements. And the visual is because we said at the very beginning, the real numbers can be found in a number line, and the imaginary numbers are imaginary. They're not on the number line. So there's no overlap. Think of a Venn diagram. There's no overlap with the real numbers and the imaginary numbers. So the intersection of that would be the empty set. All right, last one.
Union.
Union. Two sets, A and B, that are combined. Who is L. Hobbs? Mr. Trevelyan said you can come see him at the end of class. Let me get this to you real quick. The notation for union, I love it. It's a U without the stem. Good.
So a horseshoe.
Yeah, horseshoe, upright.
Or U as in union.
Yeah. I mean, I was gonna say it too.
We get the upside down horseshoe and the normal horseshoe.
I know. So let's don't call them both horseshoes because that's confusing. We're gonna call it U for union or the N for and because it means and both of them. Now, I want you to think the word or. You know how on the last one we wrote think in the word and? Now I want you to write think or. I'm going to explain where I'm going with that in a second. Before we jump to my explanation of how to remember which one's which, let's draw an example. Let's go simple. A is 0, 1, 2. Ooh, forgot the comma. 2. And B is 2, 3, 4. And the directions say find, not A-U-D in Alabama, but find the union of set A and B. Well, union means it's two sets combined, right? So, I'm going to write it out. A union B would be the set. It really helps to count in order, by the way. Would be the set what? Let's go to A. 0. 1, 2. Jump to B. 3. Why did you not repeat 2? It's already there. It's already there. So 3, 4. That's it, right? Make note. Don't repeat elements. appear in both groups. Don't write them more than once when you go to write your union. All right, now let me talk to you. We're done writing. Now I just need you to listen and think. Okay, what's your name? What's your name? Pierce. Okay. I might not send you to the store since that took so long. But anyways, if I said, Pierce, I need you to go to the dollar store and get me a Coke or a Sprite. Right? Visualize that. You drive to the dollar store, you get a Coke or a Sprite. You come back to me. What are the ways that you could satisfy my request? You could bring me a Sprite. You could bring me
A Coke.
Go with a Coke.
Or you bring a Coke.
Or you could have said, you know what, I just really wanted to make your day. You said Coke or Sprite, I just went ahead and got you Coke. Does that still satisfy my request? Yes. Change the scenario. Pierce. Right. What? Pierce. Go to the dollar store and get me a Coke and a Sprite.
Both.
There is only one way to meet that request, and that is buying both, right? So if you say and, it's more restrictive. You have to meet both conditions. If you say or, it's like the whole family. You could do one, you could do the other, you could say, you know what, I got you both of them. So which category is bigger? Or. And a lot of people think and is bigger. It's not. And is a more restricted category. Alright, so what's your homework? Because we're in the review, I printed a paper. It is not the whole thing. It's odd only. And it's only up to 35.
35.
Welcome to college!
35.
Odd. Take 36 and cut it in half.
That's 22.
Here.
Use yours.
You.
Break that desk, they're going to send me more. I know, but
Hey, we need napkins back here.
is it water?
It's Coca-Cola.
Coca-Cola.
I'll get you some napkins.
Alrighty.
I got you some napkins, girl.
Thank you, honey.
You want tea penny or you want paper towels? Odd. 1 through 35, odd. Look, I got a couple. I brought these from home in case. We're moving on up from the toilet paper.
I got it on one page. It's not page.
Right. Hey, let me say one more thing. Listen, please try.
Yes, ma'am.
Please try. It's like practice. I'm going to go to football because it's always what I go to. It would be like at practice if the quarterback threw a pass for a certain play and it was absolutely botched. Coach is not going to say, don't worry about it. You know what? We'll chalk that up as an L whenever we run it in the game. Coach is going to say, try it again, right? Please practice and try these problems. I can work with guesses. I can't work with blank. Do I? Which one's
This one
QB1?
right here.
QB1? Are you QB1?
Yes. You want?
Who's QB2?